Hi students, in this class we shall discuss applications of determinants and matrices. Applications of determinants and matrices in solving a system of linear equations. We will learn how to solve a system of linear equations in 2 or 3 variables. We have studied how to solve a linear equation in 2 variables using elimination method and cross multiplication method, substitution method and so on. But now in this class we will be discussing how to solve a linear equation, a pair of linear equation or a system of linear equations using determinants and matrices. Checking consistency. This part has been removed from the syllabus for the exam 2021. Okay, it is removed from the syllabus. Which part? For checking consistency. We will start with question number 7 of the exercise 4.6. Okay, so here consider the question. The question is 5x plus 2y equal to 4 and 7x plus 3y equal to 5. We have to solve it using the matrix method. Okay, we have to solve it using the matrix method. What is matrix method? Let us understand using this example. Okay, we can express this linear equation, this pair of linear equations in this form, like it is a into x equal to b. A into x equal to b, where A is a 2 by 2 matrix made of the coefficient matrix. This is A is equal to 5, then 2, then 7 and 3. Okay, this is our first matrix. How is it formed? It is formed using the coefficients of the given equations. Okay, next, what is x? X is made up of the variables. X is made up of the variables. X is made up of the variables. Which are the variables? Variables are x and y. Okay, we need to find this value of x. And what is b? B is the constant on the right hand side. And what is b? B is equal to the constants on the right hand side. This is 4 and this is 5. Okay, we are just using the coefficients and converting this thing like this. Now this system is said to be consistent if and only if the determinant of A is non-zero. Okay, we have to find out determinant of A. What is determinant of A? Determinant of A is, this is 5, 2, 7 and 3. This is determinant of A. Okay, that will be equal to 5 3s are 15 minus 7 into 2 is equal to 14, and this is equal to 1, and this is not equal to 0. So therefore the given system is consistent and has a unique solution. Okay, now how to solve this using the matrix method? Let us understand here. Okay, consider, we know that it is A into x equal to b. Okay, let me write this again. This is Ax equal to b. Okay, now if I multiply A inverse on both sides, this A inverse into A will become I, and hence it will become x will be equal to A inverse into b. That's it. Okay, so that is x will be equal to A inverse into b. X means capital X will be equal to A inverse into b. That's it. Now let us find the solutions. So for that purpose we need to find out A inverse. Okay, we need to find out A inverse. To find A inverse, we need to find out the adjoint first of all. Determinant is already found out to be 1. Okay, now adjoint of A. What is adjoint of A? What is adjoint of A? Adjoint of A, we know that we have the shortcut method to find the adjoint of A, right? How to find the adjoint of A? We will just interchange the principal diagonal elements. So it becomes 3 and 5 here. Okay, look at A. And then change the sign of the secondary diagonal elements, that is minus 2 here and 7 negative. Okay, so this is we have minus 7 here. Okay, Now adjoint of A is here. Now how to find inverse of A? Inverse of A. A inverse will be equal to 1 by determinant of A, 1 by determinant of A into adjoint of A. Okay, adjoint of A. So that is equal to adjoint of A itself, because determinant of A is 1, so it is 1 by 1 into, it is 3 minus 2 minus 7 and 5. Okay, I have written this here. So finally A inverse is nothing else but 3 minus 2 minus 7 and 5. Okay, this is A inverse. Now we have B here. X will be equal to A inverse into B. Okay, X will be equal to A inverse into B. Now X will be equal to A inverse into B. Okay, so let us find out A inverse into B. So A inverse is 3 minus 2, this is minus 7 and this is 5, into B. What is B? B is 4, 5. Okay, B is 4 and 5. You know how to multiply these two matrices. This is a 2 by 2 matrix. This is a inverse is a 2 by 2 matrix, and B is a 2 by 1 matrix. So the resulting matrix will be a 2 by 1 matrix. Okay, so that's it. So how to find out? So we have a 2 by 1 matrix left. Okay, it is a 2 by 1 matrix. So it will be 3 4s are 12 minus 5 2s are 10 and 7 4s are 28 negative and plus 5 5s are 25. Okay, so that's it. So 12 minus 10 is equal to 2 and 28 minus 25 is equal to minus 3. Okay, so we have 2 and minus 3. So this is nothing else but x. Okay, that is equal to x comma y. So we have what we have, first element is equal to the first element, second element equal to the second element. This implies x will be equal to 2 and y equal to minus of 3. This is the solution. Now let us take one more example. This is again of a 2 by 2 matrix. Now we shall take a 3 by 3 matrix. Okay, let us take a 3 by 3 matrix. Now we will try to solve this 3 by 3 matrix using matrix method. Question number 12. Okay, so now let us solve this. So again we will form the coefficient matrix. We know by matrix method. Okay, what do? We find A, right? We can write A into x. A into x equal to B, where we have A equal to, what is A? A will be equal to 1 minus 1 1. This is 2 1 minus 3. This is 1 1 and 1. Okay, so that is our matrix A. Then we have our x matrix, the variable matrix, that is a column matrix. Okay, so the column matrix will be nothing else but x, y and z. Okay, x, y and z, and that last one is B. B will be equal to 4 0 and 2. Okay, we first check whether the determinant value of A is non-zero or not. So first of all we will check determinant value of A. Determinant of A will be equal to, so we will write down the determinant 1 minus 1 1, then we have 2 1 and minus 3, then we have 1 1 and 1. Find the determinant. Okay, so that will be equal to 1 into 1 minus 3, that is 1 minus 3, it is plus 3 now. Then minus of minus 1 will become plus 1 into 2 ones are 2 plus 3, it is 2 plus 3 minus plus 1 into 2 minus 1. Okay, on solving you get 1 into 4 plus 1 into 6, sorry, 5 plus 1 into 1. Okay, so this is 4, this is 5 and this is 1. So 5 plus 5 is equal to 10 and this is not equal to 0. So we have determinant of A equal to 10 and which is not equal to 0. So the solution exists. We have a unique solution. So therefore determinant of A is not equal to 0. This implies A is non-singular and A inverse exists. Okay, so we will find out A inverse. How to find out A inverse? We have studied in previous class how to find out A inverse. Okay, first of all we will find out adjoint of A. Adjoint of A. How to find out adjoint of A? We will replace each element of A by its cofactor. Replace each element of A by its cofactor. So we will replace this thing by 1 minus 3. 1 plus 3, that is equal to 4, right? We have 4 here. Same way we can have 2 here. Here we have 2, then we have minus 5, then we have 0, then we have 5, then we have 1, minus 2 and 3. Okay, this is the adjoint. I have already directly taken the transpose also. I am reading row wise, writing column wise. Reading row wise, the cofactor of minus 1 is minus 5. The cofactor of minus 1 is minus 5. The cofactor of 1 is 1. The cofactor of 2 is written here. The cofactor of 1 is written here. The cofactor of minus 3 is written here. So I am reading row wise and writing column wise. Okay, adjoint of A is ready, and same way we have a determinant of A which is not equal to 0. Therefore, this implies A inverse equal to adjoint of A divided by determinant of A. Okay, so that can be done. So 1 by 10 into this determinant. 1 by 10 into this determinant. So I shall copy and paste it there. Okay, so I'll put it here. Okay, now x will be equal to the solution x will be equal to A inverse into B. Okay, so therefore what we get here is 1 by 10 into this matrix. Okay, then what we have is B is x, y and z. Sorry, B is 4, 0, 2. B is equal to 4, 0 and 2. Okay, now we shall multiply this matrix and this matrix, and finally we will multiply this 1 by 10. So this is 1 by 10 into first row by first column, second row by first column, and third row by first column. So 4 4s are 16 plus, so this becomes 16 plus 2 into 0 is 0 plus 2 into 2 is 4. Okay, then the second element would be 5 4s are 20 minus 20, 0 into 0 is 0 plus 0 plus 5 into 0 is 0. 5 2s are 10, so we have 10 here. Same way 4 1s are 4, minus 2 into 0 is 0, and then 3 2s are 6. So finally what we have here is 1 by 10 into 1 by 10 into 1 by 10 into 16 plus 4. 16 plus 4 is 20, minus 20 plus 10 is equal to again minus 10, then 4 plus 6 is 10. Okay, we have this solution here. So that will be equal to, if you multiply this 10 into each one of these elements, what you get here is, set when you divide it by 10, we get 2, then minus 1 and 1. Okay, so this implies this is your x. Okay, so therefore this implies x will be equal to 2, y will be equal to minus 1, and z will be equal to 1. So that's your answer. This is your answer. So hope you are clear with this topic. So this is how we need to solve. Now let us understand this in a general sense. Okay, the matrix method of solving a system of linear equation. Okay, so let look at this. Let us consider the system of linear equations like this. This is the general form of linear equation in 3 variables x, y and z. Okay, so a1x plus b1y plus c1z equal to d1. Same way a2x plus b2y plus c2z equal to d2, and a3x plus b3y plus c3z equal to d3. These are 3 linear equations given to you. Next, we prepare A as the coefficient matrix. What is the coefficient matrix? Coefficient matrix is A1, B1, C1, A2, B2, C2, A3, B3, C3 written here. This is the coefficient matrix. This is the coefficient matrix. Okay, this is the variable matrix. Okay, this is the constant matrix. The constant part, we write them in such a way that the constants are on the right hand side. The constant matrix. Okay, so once we form the matrices, we can write the system of linear equations in this form, Ax equal to B form, Ax equal to B form. Okay, so that is this, A into X equal to B. This is your A, this is your X, and this is your B. Okay, so A into X equal to B. Okay, so A1x plus B1y plus C1z is equal to D1. A2x plus B2y plus C2z equal to D2. A3x plus B3y plus C3z equal to D3. So the equations can be represented in a matrix form like this. Now we check whether the matrix is singular or not. That is, whether the inverse exists or not by finding the determinant. Once if the matrix is non-singular, then the inverse exists. Okay, the inverse exists, and by pre-multiplying A inverse to both sides, as we had shown before, Ax is equal to B. So multiplying A inverse on the left hand side, that is called pre-multiplying by A inverse. Okay, so this part becomes I, and A inverse into B is left behind on the right hand side. So x equal to A inverse into B. Okay, this expression is what we need. Okay, this is the expression. Now this expression will give you finding A inverse into B will give you the correct solution, or the unique solution. Okay, this method is called the matrix method of solving a pair of linear equations, or a system of linear equations, because it may have more than 2. So in that case we say it is a system of linear equations. In the first case only, which is there in our syllabus. Okay, that is, if it is a non-singular matrix, we will find the inverse, and hence find the solution of the given given system of linear equations. Okay, so thank you. Try more examples and come back to me.